In this video, we're going to learn how to add and subtract mixed numbers. So for our vocabulary, we're going to add in two terms that I've used before, but we haven't actually defined. So the first one is a common denominator. This is when fractions have the same denominator. You always need this when you're adding or subtracting fractions, whether they're mixed numbers, improper fractions, or not. You do not need this when you're multiplying or dividing, but you always need it when you're adding or subtracting. That's very important to remember. The next term is a simplified fraction. So a simplified fraction, that's what we want. That's when the numerator and denominator of the fraction do not have any common factors. So it could be an improper fraction and still be simplified. It could be a normal fraction and be simplified, but we always want it to be simplified for our final answer. So let's write a little example for that. Let's say that we have 6/12. We would always want to simplify that to be 1/2. So if you left me 6/12 as your final answer on a test, that probably wouldn't give you full credit. I need to see you simplify it. All right, so let's start out by saying that we have some common denominators with our mixed numbers. So our strategy when we are adding or subtracting mixed numbers is always going to be to convert to improper fractions first. Now, I don't want to mislead you. It is possible to do this without converting to improper fractions first, but it can get tricky and it can get a little bit weird, and you have to really understand what you're doing, or you could make mistakes sometimes. So when I'm modeling this, I'm almost always going to convert to an improper fraction first, and I want you to have that be your go-to strategy as well. So let's go ahead and convert. So 1 2/5, that's the same as 5/5 and 2/5. So that's the same as 7/5. And then 3 1/5, that's the same as 15/5 plus 1/5, which is the same as 16/5. Then I can add them just the way we learned in that first video. So 7 plus 16 gives us 23/5. And then it's nice to convert back to a mixed number. A mixed number is kind of a more simplified answer than an improper fraction. So to simplify, 5 goes into 23 4 times, leaving you with 3 left over. So 4 remainder 3. So that's equivalent to 4 3/5. So now some of you that have maybe learned this before might see, hey, wait, that's the same as if I just add the big numbers and then add the fractions. 1 plus 3 is 4, 2/5 plus 1/5 is 3/5. That's true. Next we'll do one that doesn't work out quite that nice, so that we can see why converting to improper fractions can help avoid confusion. Okay, so now I want you to pause. Now I want you to try adding 2 6/7 plus 3 5/7. Do that by converting to improper fractions first. So first I convert 2 6/7 into 27, and 3 5/7 into 26/7. And I add those together to get 46/7. And then I need to divide 46 by 7. And I know 7 goes into 46 6 times, leaving me with, or because it goes 6 times 7 is 42. And then I have a remainder of 5. So that means that 46/7 is equivalent to 6 5/7. Just kidding. 46 minus 42 is 4. So it's 6 remainder 4, which means this is 6 4/7. And so now if you look, you'll see 2 plus 3 does not give you 6. All right, so if you can see what happened there and why this didn't follow the same pattern as the first one, that's awesome. If you don't see it, that's fine. Maybe you'll see it by the end of this unit, but for right now, always convert to improper fractions first. Okay, so now let's work on how to do this when you don't have common denominators. And the process is exactly the same, except as your first step, you need to make a common denominator. So you just have one more thing to do. So let's start by adding 5½ plus 3 2/3. So first, let's convert these into our improper fractions, and then let's make a common denominator. You can do it the other order too. You can make the common denominator first if you want. It doesn't really matter. So 5½ is going to become 10 halves plus 1/2, which is 11 halves. And 3 2/3 is going to become 9/3 plus 2/3, which is 11/3. Interesting. But we can't just add those. The numerator being the same doesn't actually help us very much because we still need to make a common denominator. And the least common multiple of 2 and 3 is 6. So I need to rewrite each of these to have 6 as the denominator. So 2 times 3 gives me 6. So 11 times 3 would give me 33. And 3 times 2 gives me 6. So 11 times 2 gives me 22. So now I'm adding 33 sixths plus 22 sixths, which gives me 55 sixths. And I can convert that back by doing how many times does 6 go into 55? And I know 6 goes into 55 9 times, because 6 times 9 is 54, leaving me 1 left over. So this is equivalent to 9 1/6. All right, so now I want you to pause and try one. This time we're going to subtract. We've just been doing a bunch of addition problems. Subtraction works exactly the same way. You're going to subtract 10 1/8 from 3 3/4. Pause now. All right, so we're going to start by converting to improper fractions. So 8 1/10 is equivalent to 81/8. And 3 3/4 is equivalent to 15/4. So then I need to subtract 15/4 from 81/8. However, I can't do it yet because I still don't have a common denominator. So I'm going to continue right over here, and I'm going to make my common denominator for 81/8 minus 15/4. So the first step in a common denominator is finding the lowest common multiple of 8 and 4, which is 8. You can use a cake to prove that. And so now I need to rewrite my fractions. Well, 81/8, that already is an 8. That's awesome. 15/4, however, is not. But it's not too bad to convert because 4 times 2 gives me 8. So then I need to do 15 times 2, which gives me 30. And now I'm ready to subtract. So I do 81 minus 30, which gives me 51/8. And then of course I'm not quite done yet because I need to see how many times 8 goes into 51, which is 6, because 8 times 6 is 48, leaving me with 3 left over. So now I have 6 remainder 3, so this leaves me with 6 3/8. We made it. Okay, now it's time for a practice problem. So for your practice problem, please do 2 1/2 minus 1 4/5. Notice I'm asking you to subtract again this time. We'll check this in class together tomorrow.